Myself, Karanam Ajit Assistant Professor, Vijayanagara College, Hosapete. Now in today's topic is on Newton's Laplace formula for velocity of sound in air. Now let us understand. According to Newton, whenever the sound wave propagates in air, compressions and rarefactions takes place. So, whenever the sound wave, which when being incident upon a surface, when this sound wave, which when being incident upon the surface, at the point of contact, all the air particles compresses. When all the particles compresses, the pressure increases by decreasing the volume, called as compression. When this sound wave, which when being reflected, then the pressure decreases by increasing the volume. That means it is called rarefactions. That means during rarefaction, the pressure decreases by increasing the volume, called as rarefaction. That means whenever this sound wave, which when being incident upon a surface, these compressions and rarefactions takes place. And according to Newton, these pressure and volume changes are isothermal in nature. So, whenever this sound wave, which when being incident upon the medium, the compressions and rarefaction takes place, and these changes are isothermal in nature. Now, as they are isothermal in nature, according to Boyle's law, the pressure into volume is constant. PV is constant. Now, when P into V is a constant, P is pressure, V is volume of air. Now, we shall differentiate this equation on account of differentiating this equation by UV method. First, P is constant. Differentiation of V is dV plus V is constant. Differentiation of P is dP, that is equal to 0. Or P dV is equal to minus V dP. Or P is equal to minus V dP by dV. That is equal to minus dP by, if you transfer V to the denominator, it becomes denominator of denominator. That is given by minus dP by dV by V. This is nothing but change in pressure to the change in volume to the original volume. That is called bulk modulus. Therefore, P is equal to B, that is nothing but bulk modulus, that is equal to minus dP by dV by V. So, the velocity is given by square root of B by rho. That is, in terms of bulk modulus, velocity is equal to square root of B by rho, or velocity is equal to square root of P by rho. P is pressure and rho is density. At normal temperature and pressure, the atmospheric pressure P is equal to 1.013 into 10 raised to 5 Newton per meter square. And the density of air is rho, that is equal to 1.293 kg per meter cube. On substitution of these two values in the expression of velocity, we get this value as 280 meter per second. And this value is nearly 16% less than experimental value and is not in agreement with experimental values. Therefore, the person called Laplace made correction to the Newton's statement that whenever the sound wave, which when being incident upon the medium, no doubt pressure and volume changes, but these changes are not isothermal but is adiabatic, and has made gamma correction to the Newton statement. And gamma is defined as the ratio of specific heat, that is given by specific heat of gas at constant pressure to the specific heat of gas at constant volume, and this ratio is given by 1.4 for air, and this ratio is called adiabatic index, and gamma is called adiabatic index. And in an adiabatic process, PV to the power of gamma is constant. Now we shall differentiate. Differentiating this expression by UV method, we get, first we shall keep V to the power of gamma constant. Differentiation of P is dP plus P is constant. Differentiation of V to the power of gamma is like x to the power of n. Differentiation of x to the power of n is n x to the power of n minus 1. In the same way, the differentiation of V to the power of gamma is gamma V to the power of gamma minus 1, and differentiation of V is dV, that is equal to 0. Now we shall divide this complete expression by V to the power of gamma minus 1. Then we get, the first term is V to the power of gamma into dP by V to the power of gamma minus 1 plus P gamma V to the power of gamma minus 1 into dP, that into dV by V to the power of gamma minus 1 is equal to 0. Here V to the power of gamma minus 1 cancels. And now we shall simplify this term, that is V to the power of gamma into, if you transfer this term to the numerator, the negative power, the positive becomes negative power, V to the power of minus of gamma minus 1. Now if you take this value here, when the bases are same, powers can be added. That is given by V to the power of gamma minus gamma minus gamma, minus into minus is plus 1, and gamma plus gamma minus gamma cancels. We get this as V. That means this complete term becomes V. That we can take here. That means when we substitute here, this complete term becomes V into dP plus this is given by P gamma into dV is equal to 0. That is the expression V dP plus gamma P dV is equal to 0. Or dP is equal to minus, that is gamma into P. This value of gamma into P is equal to minus dP by dV by V. That is equal to bulk modulus. The bulk modulus is given by B is equal to minus dP by dV by V, that is equal to gamma P. That means, in other words, the bulk modulus is equal to gamma into P, where gamma is adiabatic index and B is bulk modulus and V is called as velocity. Therefore, the velocity of sound is given by V is equal to square root of B by rho, that is equal to B. In place of B, we take this as gamma P by rho, or the velocity is equal to square root of gamma P by rho, which is an expression for the velocity of sound. This value of velocity of sound is given by square root of gamma P by rho. Now let us substitute this value of pressure. Pressure as 1.013 into 10 raised to 5 Newton per meter square, and the density of air is 1.293 into 10 raised to 1.293 kg per meter cube, and gamma is 1.4. On substitution, we get this as 332 meter per second, and this value is in agreement with experimental value. As this value is in agreement with experimental value, hence this relation is called as Newton's Laplace formula for velocity of sound in air. Hence the Newton's Laplace formula. Thank you.